In this video, I want to talk about what actually do we mean by econometrics. So econometrics is in general a statistical toolset which helps us to evaluate some sort of relationship of interest. So an example might be we're interested in, for individuals, what is the effect of an individual's level of education on the average wage which that individual might expect to obtain. So if an individual's level of education increases, we might expect that the level of wages which an individual obtains on average might increase. So if I was to plot a graph of the level of education of individuals on the x-axis against the sort of wages which a group of individuals have obtained on the y-axis, then we might hope to see some sort of positive correlation between these two variables. That's not to say that it's necessarily a causal relationship, only that there is some sort of positive relationship between these two variables. Well, econometrics helps us to quantify this degree of correlation by, in a sense, drawing a sort of line through the centre of all those points. And by drawing a line through the centre of all those points, we are hoping to capture what is the average effect of education on wages. So, on average, an individual who, let's say, has 10 years of education might expect to obtain a wage which is, let's say, $400. Whereas an individual, perhaps if they had 11 years worth of education, might expect their wages to go up by $100. So perhaps they now earn $500. Well, econometrics is a tool set for actually finding out what the strength of this relationship is. So how much does wages actually go up by? And this type of relationship here, where we're concerned with sort of the relationship for individual people or individual firms, is the sort of subject of microeconometrics. Yeah, and it's called microeconometrics for sort of analogy with microeconomics. Another sort of microeconometric relationship we might be interested in might be, what is the effect of, let's say, TV advertising on a company's level of sales? So if I was to draw a sort of graph of a company's level of sales over time, then we might have something which looks something like this if there's some sort of seasonality. Perhaps this is coffee sales or ice cream sales. And we might be interested in, do these sort of peaks which we observe in the data, are they caused by, let's say, TV advertising? And TV advertising might look something like these sort of bars which I've drawn below. So econometrics is a way of sort of understanding for this sort of time series data, does this sort of TV advertising here cause sales to go up? And similarly, does this TV advertising here cause sales to go up? So this is slightly different to the previous example in that we're dealing with what we call time series data, whereas the original data was what we call cross-sectional data. But it's still actually what we call microeconometric data because we're dealing with data for a particular firm. Another type of econometrics is the subject of macroeconometrics. And macroeconometrics, as its name sort of suggests, is to deal with macro relationships. So an example here might be, what is the effect of interest rate falls on inflation? So traditional economic theory suggests that if the interest rate falls, then the inflation rate should increase because of increases in aggregate demand. So econometrics is a way of quantifying that particular relationship. So all of these relationships are sort of variations on the same sort of theme which we see time and time again in econometrics. So the idea with econometrics is that there is some sort of population, or in the case of sort of time series data, we actually call this a data generating process. But you can kind of think about it, for now at least, in terms of a population. And within this population, there is some sort of true relationship between the variables which we're interested in. So there might be some sort of true relationship between an individual's level of wages and, let's say, their level of education. So in this example here, sort of beta here quantifies the effect of 1 year of education on an individual's level of average wages. But there are other factors which also determine wages, which we sort of group together in our sort of population error U, which are all these sort of other idiosyncratic factors which also affect an individual's level of wages. So an example might be, where does the individual live? Are they based in OECD countries, for example? What are their sort of interests? Are they interested in pursuing a career where they earn lots of money, like an investment banker? Or are they interested in going into the civil service, for example? Those are all the sort of things which are contained within our population error U. But the idea with econometrics is that we don't actually have the entirety of the population in terms of our sort of data set. In general, we only have a sample from that population because we deal with non-experimental data. So we just sort of get we hope to get a randomized sample from the population. And the idea with econometrics is that by applying some sort of tool to this sample data set, we hope to actually estimate these parameters. So in this case here, we hope to come up with estimates of beta and perhaps alpha. So that's what we hope to get out by our econometric analysis on this particular sample. But in general, these sample estimates will differ from the actual population true values because of the fact that our sample isn't necessarily perfectly indicative of what's going on in the population. And we actually have a name for this effect, which we call sampling error. And the idea with econometrics is that we want to use tools which actually reduce this sort of sampling error as much as possible. So they make our sort of estimates which we produce on the sample as close to the true population values as possible. And also, by doing so, that will allow us to make some sort of inference about what's going on in the population. So is the true effect of education on wages, let's say $100 per extra year of education? In the next video, I want to talk about the difference between econometrics and hard science, where in hard science we can actually carry out experiments where, let's say, we would only increase an individual's level of education holding all other factors constant. In reality, we can't actually do that. So econometrics is our sort of way of dealing with non-experimentally generated data. I hope to see you in the next video.